Okay, then let's get started. We are in chapter 8, section 2. So last time we had, let me see, which problem. Okay, so we are in example 3, right? So we started that problem, testing hypothesis by using p-value methods. Okay, so remember last time we have set up, what is that? The hypothesis, right? So what was that? So what is my H naught and H1? So if you look at the problem, my population parameter is mu. So it was son, and the next one was right tail test with 5700, right? So we had the picture. So we had the picture for this problem. Oops. Okay, so we had a right tail test. Okay, so remember we are doing this problem by a p-value method. So therefore, for p-value, we don't need to find the critical value. Instead of, we need to find the test value, right? So this is my test value. So remember last time we got the answer for my test value. So we used the z as my test value. The formula says that is x bar minus mu over standard deviation divided by square root n, and we had the numbers here 59, 50, and we will subtract with mean, and we had 659. Then we have divided this by 36, right? Then we got this test value z value as 2.28 last time. Okay, that means my test value here is 2.28, this value. So now the area, anything, in the right side of this point is going to be the p-value, right? P-value is basically area of, uh, of this region. Okay, so then how do you find this area? You could use either calculator. Remember, this is my z distribution, or you could use your table. Okay, so remember, if you're plugging this value into your calculator, always will give you a left area, then you have to subtract from 1, whatever you are getting, right, to get the right area. Okay, therefore, what is my p-value? Is there anyone found this answer? So you need to find this area now. So let us find first, the left area, this guy, to that point. So we need to go for second var. I need now area, right? So you have to go for normal CDF, and I need to find now. Oh, wait a minute. I think we could find directly, right, by using this function. So my left bound for this area, I don't need to find the left area. Directly we will find the right area. So this is my right left point, and my right point is infinity, right, for the bound. Therefore, I'm using that. So 2.28, and E99. So what is that? Okay, so now this is my area. So that is point 1 1 2. Is that 3 4 or 3 3? 3 is a 3, right? Okay, so now this is my p-value. Okay, so now once you have p-value, what is your decision then? So you have to check whether the p-value is less than alpha. So where's my alpha here? The significance level for this problem, alpha is 0.05 given. Therefore, my alpha is 0.05. Now consider these two numbers and compare with what is bigger. So it is clear that my p-value is now going to be bigger, right? Did I miss any number here? No, you see I missed 1 0 here. It's not correct. There's a 0 here. 0.0113. So therefore my p-value is smaller than alpha. Okay, so let me erase this and write in clearly. That is 0.0113. So this is much smaller than your alpha. Therefore, what is my decision? When p-value is smaller than alpha, we reject, right? So we reject. Okay. Therefore, write down your summary. So my summary is what? There's enough evidence to support your claim, right? So there is enough evidence to support our claim and support the claim. Okay, that means what? That means our claim is correct, right? The tuition and fees should be greater than 5,700. Okay. So this is the method we use p-value. Okay, so the thing is now you could use your calculator to test hypothesis. Okay, so let me use my TI-83. Right. Remember, we are finding z values. Therefore, I need to go for z test in your calculator. Okay. So let us do this problem. So the calculator will give you the p-value. So we will find the p-value and the test value. So calculator will give you both of them. Okay. So now let's do this problem by using the calculator then. Okay. So let us go to stats. I'm writing here this step. Okay. Go to stats. Then what I want. Then I need a test. Go to test. Then I need the number one z test. Okay. So go to test and we use z test. Okay. So let's follow this procedure then. So z test is number one. Okay, I'm entering. Okay, now we have to input data like we did, in finding confidence interval. The same thing here. Okay, so now the thing is you have to look at your hypothesis setup and plugging these values. Okay, I have now stats, right? I don't have data, so I'm going to use stats and enter. And number two, mu naught. The mu naught is your value in your problem. You see now the problem mu naught calculator says mu naught, that is my mu. So you are plugging this value there in your calculator. So that's what I have here, 5,700. Okay. Then the standard deviation, the population standard deviation for this problem, they say that it is, where's that? The population standard deviation is 659. Then x bar is my sample mean. So it is also given, you remember, there are 36 of them. There are 36. My sample size is 36, and my X bar is going to be there's 5950. So plugging those two values here, and the little n is 36, my sample size. Okay, now here you have to choose the correct tail test. Which tail now we have? We have, my alternate says that it is a bigger than sign, therefore you have to choose the bigger than mu naught. Mu naught is here that number we entered, 5700, okay? So therefore here my test is right tail test, so I am choosing that, greater than sign, right? That's it. Then go to the calculate, enter. Okay, so this is the summarize the things it will give you the calculator, right? Okay, so now look at the Z 2.2 or 2.228. What is this value? This is your Z test value. Okay, C test value. We got that right, 2.28. Remember here we got test value 2.28. So that is my test value. P-value, okay, so we got here 0.0113, calculator is given 0.0114, small difference, but it is very small, so you could neglect the difference, right? So the calculator p-value is 0.0114. So you could write that one if you use the calculator instead of 0.0113. Okay, anyway, our p-value is now going to be less than alpha, right? Alpha is 0.05. So now this is up to you now, right? So if you use the calculator, it's very pretty straightforward. So it will give you all the, the values, whatever we want, right? So you could use this calculator for our traditional method also, right? Only thing is, for the traditional method, we need to know the critical value, right? So find the critical value, then use the calculator. Then calculator will give you the test value. Then compare whether the test value is, falling in a critical region or not. So you could use in either way. But my suggestion is, when you are asked to do p-value method, the calculator will give you a straightforward answer. So you just take these two values and compare, right? Your p-value and alpha. That make sense? So if you have questions, please ask. Okay, so now here, this problem also about p-value, right? So I'm just straightly using calculator and show you how easy, So now for this problem, example 4, a researcher claims that the average wind speed in a certain city is 8 miles per hour. A sample of 32 days has an average of 8.2, right? So let me write down then all the things. So my sample size is here 32, and the claim mu was 8, and the X bar, the sample mean was 8.2, and the alpha is 0.05, and what the standard deviation for the population is 0.6. That's it, no? So we know all the numbers here. You see now? If you read the question carefully, the researcher's claim was what? The average is 8, right? He's going to check whether that is correct or wrong. So therefore, you have to put a not equal sign in your alternate, right? So we don't have, whether he wants less than or bigger than. Instead, he's just checking whether it is 8. Therefore, your alternate is going to be not equal to 8. So this is two-tail test now, right? This is now two-tail. So two-tail test. That is why you have the picture like this. Now you have two areas, right? So your alpha over 2 is now 0.025, right? Because you need to divide into two pieces, okay? right? So now here they use the manual method, and you find the test value is 1.89. Okay, so after that they use the either table or the calculator to find the area, right? So remember, now you have now two tail, so therefore you have two areas. Now um remember, this is my p-value of half, right? Whatever you get the p-value, now you are divide by 2. Why it is? Because now you are distributing your p-value into two pieces, right? This side also p-value. Whatever you get the p-value, then you have to divide by 2. Okay. So that means now you need to compare your p-value divided by 2 to alpha over 2, right? Because now you need to compare p over 2 to alpha over 2. Okay. So so if you use the calculator, then let's see how it's happened. I'm using the calculator. So stat, go to test, and again the test, and okay, let us input our data. Then what is mu naught now? Mu naught is 8. And what is my standard deviation? It is 0.6. And what is my x bar? 8.2. And what is little n? 32. Okay, now I need that two-tail test, right? So you have to choose the first one, then calculate. Remember, this is just the p-value, right? But you need to compare p over 2 because of two sides. So if p is 0.059 this value, then you have to divide by that 2 and compare with alpha over 2, or directly you could compare this p-value with the alpha. Both methods are okay. So compare whether this is true. So that is equivalent to check, this, no? So you should understand that even though I have two areas, but both areas are, same. So instead of comparing p over 2 with alpha over 2, I'm going to check whether that is less than or not. I don't know still. Okay, that's why I'm putting question mark. So you could choose p over 2 with alpha over 2 comparing, or p over p and alpha, right? Because both sides you have to, you could cancel. So either way, check in either way. But the calculator is given p-value, so you could check with alpha directly. So where's my alpha then? 0.05. Okay, so my p-value is now 0.05. Oh, this is now bigger than 0.05, right? So now that means this is not correct. So this formula says that the p-value is now 0.0593, but my alpha says that 0.05, so that is bigger than, so p is bigger than alpha. Therefore, what is my decision? Decision we cannot reject. There's no enough evidence to reject, right? Therefore, your decision is to not reject the null hypothesis because the p-value is now greater than 0.05. Okay? So only thing is we have to understand the picture correctly. Okay, so you have plenty of problems to practice. So why don't you try this out? So if you have any questions, please ask. If it is not, then move to 8.3. Okay, again, we are going to use the testing hypothesis for mean, but the second case, now here you don't know standard deviation, right? So remember, when you find a confidence interval for mu, we had exactly the same situations, right? So if you do not know the population standard deviation, then you can't use a z value. Instead of that, we are going to use the t value now, t distribution, right? So now here again we are using the hypothesis for mean, right? So testing for mean, but now when sigma is unknown, so now you don't know population standard deviation. Okay, so now this is the case we have here in 8.3. Everything is much similar, right? Only thing is now instead of z distribution picture, now you have a t distribution. Remember, t distribution also similar to z distribution. Then what is the difference between t and z? Here we use the degrees of freedom, right? So the degrees of freedom is given by n minus 1. Here n is my sample size, right? If you want to use the table, remember, it will give you the right area now, unlike z distribution. Z distribution will give you left area. Now here, if you want to use the table, you have to plug in the right area, okay? So other than that, everything is much similar, like z distribution, okay? Now here, where's my test value? Here my test value is now t value. Instead of z value, now I have z value, or t value, sorry. So the formula is much similar. Only difference is now you can't put the standard deviation. You don't know. Instead of that, I'm putting my sample standard deviation, right? Bit less. Now this guy could be determined by using your sample, right? So this is my test value here. This is my test statistic. Okay, so look at here. So the degrees of freedom is n minus 1, right? So then do the same procedure, whatever we learned in 8.2. Okay, before going to do that, so let's look at these all three problems. Already worked here out, and you just make sure that you understand. Okay, so find the critical value t for the alpha, this value, right? Remember, this is left tail test. So if you look at your picture, now I have left tail test. This is my area, right? So they are asking us to find this value. This is my critical value t now. Okay, so this is my critical value CV. Remember, this is my alpha now. How much it is? It is 0.01. Okay. Then how do you find that? How do you find this value? How do you find this t? Okay, so you could use your table. So this is my t distribution table I gave you. Okay. How are we going to use this table? Remember, these all the values will be given for your alpha, but your alpha is right area. Look at this picture. So if you want to find the t value, you have to plug in the right area, okay? That is my alpha. But unfortunately, if you look at your alpha here, the maximum alpha value is 0.1, right? Oh, what does it mean by that? That means if you look at this picture, remember I told you earlier, this picture is much similar to z distribution. Therefore, here you will, if you know, say suppose if this area is 0.01, right? Then this value, let me call this as a t1. This value and this value, what is the similarity of these two values? Could you tell me? Any one of you?
Are they going to be symmetrical?
Exactly. Very,
One
yes.
be positive, the other will be the negative of that
Exactly,
same number.
exactly. Very good. So remember, this is much similar to C distribution. So if it is 0.01 this side, that means these two values supposed to be, the magnitude is, the same value, but only thing is you will get here positive sign and here negative sign, right? Right? So if you want to use the table, always remember you have to plug in the right area. So that means I'm going to check this right area. If you check this area, in your table will give you this value. That means positive value. But once you know the positive value, we have to understand that this guy is going to be negative of that, right? Okay, so now let us find my T1 then. So I'm going to check zero point zero 0.01 for my alpha. And where's my degrees of freedom for this problem? They say degrees of freedom is 24. So I'm going to check alpha is 0.01 with degrees of freedom 24. So let us check that. Remember, this is one tail problem, so you have to check the one tail here. And my alpha is now 0.1, oh sorry, 0.01, right? Here, 0.01. And your corresponding TF is degrees of freedom 24. So could you check 24 and 0.01 under one tail? So it's going to be 2.492 here, right? 2.492. So my positive T value is 2.492. That means this value is 2.492. If this is 2.492, actually I wanted this value that is going to be negative of that. That is why you have this answer, okay? Because of left tail. If it is right tail, positive value. If it is left tail, negative. Okay? So look at the second one. For the second picture, now I have right tail test. Oh, right tail test is always much straightforward, right? Because the formula, the table is always for right tail. So it's easy. So the degrees of freedom for this problem is now 16, right? So my alpha is 0.05. Now this is 0.05. Easy, much easy. So your T will be straightforward, positive answer. So now look at 0.05 with 16. So 0.05, again one tail, you have to check one tail. So 0.05 is here, right? 0.05, and I need degrees of freedom is what is the degrees of freedom? 16. So 16 is here and 0.05, what is that? That is 1.746. 1.746. So it is 1.7. So it is positive now. Fine. That is why you have positive 1.76, 1.746. Okay. But the third one, all three problems are different scenarios, right? So now this one, again, two tail now. Your alpha is 0.1. Remember, two tail means you have to distribute your alpha by two pieces now. That is why I need to divide by two now, right? So 0.21 divided by 2 is 0.05 now. Okay, 0.05. So now this also 0.05. Oh, that means what? That means now you will have two T values, right? Critical values here. Let me call this as, say, T1. This is my another point. You have two values now because of two T. Now, which one is easy to find? Remember, these two are going to be same answer, right? With this opposite sign. Remember, to find the right side is always easier because straightforward. So I'm going to look at now 0.05 with what? Degrees of freedom. It's now 18. So look at 18 with 0.05. So 18 with 0.05, zero point 0.05 here, and 18 is going to be what? 1.734. 1.734. So that means this guy is 1.734. If this is 1.734, then your left point should be negative of 1.734. Okay? So this is the way to find the critical values by using a table. Okay. Again, we have assumptions like earlier. the sample is random sample and is bigger than or equals 30 if you consider as a normally distributed, other, or it should be less than 30 if it is normal. So the same assumptions we had earlier, right? Okay then. So look at this problem now. The medical investigations claim that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Oh, you look at now. Look at now. Why we have sample standard deviation instead of population standard deviation? Let's see who is telling. Why did they give a sample standard deviation instead of population standard deviation? Because we are doing the problem under t-test value. If it is t-test value, I'm going to use this formula, right? So anyway, you should know the sample standard deviation. That is why they have given a sample standard deviation, okay? Right. So if you write all the numbers, so let's write down all the numbers then. What are the numbers? Could you tell me very quick? So he claims that the infection per week is, this is his claim, right? So that's going to be my mu, right? The random sample of 10 weeks, therefore it lane is now 10. And the mean number of, those samples is X bar, right? So which is 17.7. And the sample standard deviation is now 1.8, little x is 1.8. So my alpha is now 0.05. Remember, he's suspecting whether the mu is 16.3, right? Therefore, your alternate going to be not equals to 16.3. So it is two-tailed test, right? Okay, that is two-tailed test now. So this is my alpha over 2, that is my alpha over 2. And if you find these critical values, you don't know how to find the critical values, right? So let me call this as T1 and T2, two different values with the different signs. So if you use your so this is going to be 0.025, am I right? You need to divide by 2 now. So if you look at your table, you will figure out this, the critical value. My degrees of freedom is what? My degrees of freedom is now, what is that? Your little n is 10, right? Therefore, degrees of freedom n minus 1, which is 10 minus 1, 9. So look at 9 with 0.025, then you will figure out the corresponding critical value. 0.025, 0.025 is here. Okay, 0.025 under one tail. I'm considering under one tail because I'm considering only one area, right? That is why I'm looking at 0.025. 0.025 with 9. With 9, 0.025 with 9 is going to be 2.262. 2.262. So 2.262, that is my positive. So the negative will be here, right? That is why you have these two values for your critical, right? Remember, this colored area is going to be our critical region, right? If your test value falling in this region, then we are going to reject, right? I'm going to use the traditional method. Okay, now remember the test value here. The test value formula is x bar minus mu over little s over square root n. You know all the numbers here is there. Plugging all the numbers and find the test value. Test value says that it is 2.460. Where is that? This is positive value, right? 2.460. Remember, this value is, my critical value was, positive value was 2.26, but this guy 2.4, of course, is going to be somewhere here, right? Therefore, my test value is now going to be on the critical region. Therefore, you are going to reject. Okay. So we are rejecting our null hypothesis. So reject the null hypothesis. That means there is enough evidence to reject your null hypothesis. So we are rejecting the null hypothesis. Therefore, my claim is correct. My claim is correct. What was my claim? My claim was mu is not equals to 16.3. Okay. Does that make sense? Okay. So now for next one, let's use the calculator for the next one, okay? Because you could try this problem with p-value method, okay? So a physician claims that the Jager's maximum volume oxygen uptake is greater than the average. Okay, so now his claim was greater than, right? Therefore, it's going to be a right tail test. So the random sample of 15 joggers, so little n is 15, and my x bar is 40.6, and what is my little s? 6. So this is going to be your claim, right? So my mu is 36.7. Okay, there. So where's my alpha? Alpha is 0.05. So if you look at your picture, now this is going to be your right tail problem, right? So I'm going to use the p-value method. Therefore, this is p-value means you need to find the test value. I don't want to find what? The critical value, right? So I'm using calculator, so you don't need to do like this if you want. Here we have done in manual way, right? 2.517. But I'm using calculator and checking whether this answer we are getting test value. Okay, so let's use the calculator then. But remember, now we are going to use the t-test. So test, I'm going to use the second one now, t-test. Okay, so here use stats, go to test, then go to t-test. Right, so now let's plug in all the numbers. N is 15, so I need to know what? So input stats, okay, mu naught, where's my mu naught? 36.7. Enter. What is my x bar? X bar was 40.6. And standard deviation, sample standard deviation is now for this problem, which is 6, right? And the sample size is now 15. Okay, now what kind of test I have? Now I have greater than sign, so the last one. That's it. Calculate. Okay, it says that the t test value, t statistics is 2.517. Yes, we got correct answer here, 2.517, right? Okay, so the p-value, what is my p-value here? P-value is 0.0123. 0.0123. That's my alpha. My alpha is 0.05. Compare now these two numbers. My p-value is smaller than alpha, right? Therefore, my suggestion is a reject H naught. Much easy, no? If you use the calculator. Are you following me? Say yes or no.
Yes, sir.
Yes. What about others?
Yes, sir.
Very good. Okay. So this all about the calculator method, and you just practice, okay? Remember, we are going to do multiple choices for the final. Therefore, the calculator using is essential. So make sure that you understand how to use the calculator, okay? Okay, so this is much easier, right? Because once you understand 8.2, this is going to be easy. So let me introduce 8.4 and we will finish next time. But anyway, we have 10 minutes. I'm going to start. So 8.4, that is 8.4. Okay. Now again, we are going to use the z-test, but for the proportion, right? Remember population proportion, we use little p, right? Okay. Now again, we are going to use the hypothesis testing, much similar now. Once you understand the concept, no, the remaining all going to be much similar. Only thing is the test statistic formula will be changed, right? Use the proper formula, according to the problem. If it is proportion, use this now. Again, we are going to use the z-test, z-value now for the proportion. Remember when you had that problem, finding confidence interval for the population proportion, we had the similar thing, right? The z values. So here my test value is going to be p hat minus p over square root p times q over n. Okay, so now this is my test statistic. So what is here p hat? P hat is coming from your sample, right? So the p hat is coming from your sample. What is that? Formula says that p hat is going to be x over n, right? So let's see who's telling. What is here x? Remember under the proportion, what kind of distribution this x has? What is the distribution for this x we have under the proportion? No answer. Remember proportion. You're going to ask question. They will give either yes or no. Right? So only two answers always. Therefore, x is going to be binomial, right? So you are doing the survey kind of problems. Now what is this n? You are taking the sample. Say you are picking 50 people and you are going to ask one by one whether they like something and they will say yes or no. If it is yes, you count that as your x, right? Successes. So like that. So you are finding the proportion for your question, right? So that is why this is coming from your sample p hat. But the little p is the population proportion. That is, we don't know. So we are doing the testing hypothesis for that, right? Like mu. Here we have proportion little p. Okay, so that is why that is a proportion of a population, right? Okay, and it's my sample size. Remaining all kind of similar. So remember the relationship between p and little q is this, right? Binomial. That means the little q will be given 1 minus little p. Okay. Right. So now, but here we have different assumptions. What kind of assumptions we have for the testing proportion? The sample is random sample. The condition is for binomial experiment as satisfied in chapter 5. And n times p should be bigger than 5 and n times q also bigger than 5. So you have to check whether these three conditions are satisfied before testing your hypothesis for the proportion. Okay, so now let's look at this problem. The researcher claims that based on the information obtained from the Centers for the Disease Control and Prevention, 17% of young people ages from 2 to 19 are obese, right? To test this claim, she randomly select 200 people aged from 2 to 19 and ask checking one by one whether they have that problem, right? Then she found that out of 200, 42 had that problem, obese, right? Now, the question is there enough evidence to reject the claim? What was her claim? Her claim was, yes, this is her claim. She's checking whether 17 percentage of the young people, this is population proportion, right? So the population proportion is 17. So little p is now 17 percentage, that is 0.17. So she is suspecting whether this is true. So that's why her claim is little p population proportion not equal to 0.17. Of course, my null hypothesis is equal, right? Now her claim is this. Now her claim is this, right? For this problem, for particular problem. Okay. So find the critical values. Remember, we are using now z test value, right? Where's my test value? My test value says z. You see here, you see the letter z here, right? Because this is z distribution, these are all the values. Okay, so we are using the z distribution now. What kind of test this is? Again, this is going to be two-tailed test, right? That's my alpha. Alpha is that, so this is 0.025. This is 0.025, right? Okay, now find the critical value. You know how to find now. Now you are using Z distribution. Use the table, or you could use the calculator. So the calculator is easy. You will find the normal CDF. No, I need inverse norm, right? Because you are finding Z value. Say this is my Z2 and Z1. So you have to use inverse norm function in your calculator now to find the Z value, the inverse norm, right? So you need to plug in always left area. So left area to this point is left area for Z1 is 0.025. So if you find this value, this will give you negative answer because left area is left point, so it is negative. So if you look at that value into your calculator, no, I need now inverse norm, right? Finding Z values. So I'm plugging 0.025, but default is always 0 and 1. You don't need to. So it is negative 1.96. So this is negative 1.96. If it is negative, then this should be positive, right? That is why you have those two answers here, right? Now find the test value. You know how to find test value. So use the formula now to find the test value. Formula P hat says that x over n. What is x here? Number of people they have the problem. There are 42 of them out of 200. So use that fraction and simplify, which is 0.21. Once you know P has 0.21, keep that. And you know the little p, this is my, what's that? My hypothesis, 0.01. If p is 0.10 and 0.17, sorry, and your little q is going to be 1 minus p by using the formula, that is 1 minus 0.17, which is 0.83, right? Therefore, q is 0.83 and p is 0.17 and the little q is 0.83. So plugging all the values into your test value. This is my test value formula, right? P hat is 0.21 and subtract little p is 0.17 and plugging all the values, you will get the test value. So this is your test value, 1.51. So 1.51 is where? This is 1.96. 1.51 will be somewhere here. So it is very clear that my test value is now falling into non-critical region. Therefore, you can't reject now, right? You cannot reject. So do not reject your null hypothesis.